Hello and welcome to another video of mine. Somebody asked a question if I could make a video lesson on math. So I've decided to do that for the person. I'm going to talk about some topics that are asked on the nursing entrance exam. And I'll begin by looking at rounding of numbers. Okay. For some questions, once you finish working them out, you'll be asked to round. To maybe a nearest 10 to nearest 100 and so on. Okay, so how do you do this? So let's begin. So there are times you want to round off to a whole number or to some other specified place value, right? So it could be, we can round to 1, nearest whole number. Or to a specified place value. Okay. Now, whether you're rounding whole numbers or rational numbers, the rules are the same, right? So let's go through the rules for doing this. You can use this guideline. Okay. So first, underline the place value to which you are rounding, right? So underline. The place value to which you are rounding. Right, it's very important to do that. And then 2, you have to examine the number immediately to the right of the underlined number. So examine the number immediately to the right. Of the underlined number. And then the 3rd point, if the number to the right is 5 or greater, round the underlined number up by 1. So if the number to the right is 5 or greater, round the underlined number up by 1. And then the last step, if the number to the right is less than 5, leave the underlined number unchanged. So these are the 4 guidelines or rules I can use to round numbers. Let's look at some examples. Let's apply the rules that we have here. So let's say that I want to round to the nearest one, the nearest one, or to the nearest whole number. So if I have a number like 94.81, and I tell you round this, I say round to the nearest one. So this is what you're going to do. So first, we have to underline the place value to which you are rounding. Underline the place value to which you are rounding. So we're going to underline this one here. Okay, this is the hundreds, right? No, sorry, it's 100. This is the tens, right? This is the tens. This one is the ones. Okay. Now over here, this is the tenth, and then this place value here is the hundredth. TH at the end, because those are the decimal point, the place value of that decimal point. You add TH to them. Okay. So since I want to round to the nearest ones, it means I'm looking at this number here. So I'm going to underline that. Number 4. Right? Then I'm going to examine the number immediately to the right of the number on the line. So I have to examine this number, which is to the right. That is 8. Now, if this number is more than 5 and above, right, I have to round that number up by the underlying number up by 1. Right? So this 8 is more than 5, right? Greater than 5. So I have to round the underlying number up by 1. So it means that if I round this to the nearest 10, nearest 1, then I will have 95 as my answer. 95 as my answer. Right. So this is an approach I can use to round numbers. So let's say this is number first example. Now let's look at another example. Let's round one, 3, 4.28. We're going to round this again to the nearest one. All right, so this is the one column. All right, so I have to run this 4 up. No, sorry, I have to run this number 4, underline number 4. So I go to the number on the right. This is the number to the right of the underlying number. When I examine this number, is less than 5. So the underlying number is going to remain unchanged. So if I round this up to the nearest one, then the answer will be 134. And the underlying number remains the same. Let's try another one. I want to round to the nearest 100. And the number will be 9245. So to round to the nearest 100, the nearest 100, I have to identify the place value, the 100. This is 1, that is 10, and that is 100. So this is a number I want to round. So I'm going to examine the number to the right of the underlying number, which is this number 4. Is this number greater or less than 5? Now this number is less than 5. So because it's less than 5, I'm going to maintain the underlying number. It's going to remain unchanged. It's going to remain unchanged, right? So we'll have 9, 2, and then all the other place values will be 0, 0. Okay, 0, 0. Let's try one more. Round to the nearest 10. The nearest 10th. So this time look at the nearest 10th, right? 10th. So the number we're going to work with will be 478.396. So to round to the nearest 10th, I have to underline the place value, the 10th column. So 10th. So this is 10th, 100th, 1000th. Okay, with TH at the end. Okay, once it's TH at the end, you look at the place after the decimal point. So the 10th column, the 10th is this 3. So I'm going to examine the number to the right of this number, and that is the number 9. Is 9 greater than 5? Yes, it is. It's 5 and above, right? Anything 5 and above. So if it's 5 and above, you take it to 1. So you're going to round up the underlying number here by 1. And then the other place values will just be zeros. So if I do that, I'll end up with 478.4 as my answer. Right? So this is how you round up numbers to the nearest 10th, nearest 100th, and so on. Okay. So once you get problems like this, you should be able to do them. Usually you solve a problem and then they ask you to round them up to the, either round them up or do something else with it. Okay. Great. So I hope this helps out a little bit for those who have forgotten how to round up numbers. Okay. Now the other thing you have to think about is prime numbers. You have to know prime numbers. Prime numbers. So what are prime numbers? Prime numbers are whole numbers that have exactly 2 whole number factors. All right. So these are prime numbers are whole numbers. The keyword are whole numbers. That have exactly two whole number factors. And these are 1 and the number itself. All right, so 1 and the number itself. Now, let's think about some of these numbers. Right? For example, if we take the number 2, you can only have 2 times 1, right? So it has only 2 factors, 1 and itself. So these are the factors, 1 and 2. 2 factors. Now take a number, 3. 3 is a prime number because you can only have 3 times 1, and so on. What about 5? 5, you can only have 5 times 1. You know, what about 7? 7, you can have 7 times 1, nothing else, and so on. Okay, if we take 11, 11 times 1, nothing else. So these are prime numbers. Okay, if the number has more than 2 factors, then it cannot be a prime number. Okay, now let's look at an example. If I take a number like 9, let's take this number 9. If I take 9, right, 9 can be 9 times 1. I can also have 3 times 3. So if I look at this, the factors of 9 will be 3, 9, and 1. So 9 has 3 factors. Because it has 3 factors, that's 1, 3, and 9, more than 2 factors. Because of that, 9 is not a prime factor. So 9 is not a prime number. Sorry, prime number. It's not a prime. So this is not a prime number. Okay, more than 2 factors. Okay. Now the only prime number, so the only even prime number is 2. Very important to note that 2 is the only even prime number. So 2 is the only even prime number. Okay. Now, all other even numbers have 2 as a factor, and therefore they have more than 2 factors. Now, the opposite of prime number is a composite number, what we call a composite number. So a composite number. Okay. So a composite number, we're talking about whole number other than 0 with more than 2 factors, right? Whole numbers other than 0 with more than 2 factors. So that's what we call a composite number, more than 2 factors. So if we take like a number like the 9, right? And if we say that 9 has the following factors, you have 1, you have 3, you have 9. These are all possible factors of 9, as we've seen already. Okay, so because of that, this is an example of a composite number, right? It's also important to note that, so I'm putting asterisk against this, that 0 and 1 are neither prime nor composite, all right? 0 and 1 are neither prime or composites. Okay. Neither prime or composites. Right. So I believe now you should be able to identify composite numbers and also prime numbers when you are given a problem. Now, the other thing that I want us to look at is average. Average. Okay. We asked to find averages. So what is average? Another word for average is the word mean. So say find a mean of a group of numbers, then they ask you to find the average. Okay. So what do you mean by average? The average of a group of numbers is the sum of the numbers divided by number of numbers added, right? So the average or mean of a group of numbers is the sum of the numbers divided by, so divided by the number of numbers added. Okay. In other words, you add all the numbers and divide them by how many numbers that you have in the data set. Okay. Now let's take an example. Now, what will be the average, okay, of 5, 9, and 10? Okay, 5, 9, and 10. So what we have to do here is to add all the numbers. So 5 plus 9 plus 10. And then divide by how many numbers? We have 1, 2, 3. 3 numbers. So we divide by 3. So this will be equal to 24 divided by 3. And that gives us 8. Okay. Okay. So what does this mean? Now this means that if you take the numbers and divide them equally, you're going to get like each one is going to be 8. Okay, that's the mean of average. Okay. Okay. So this one way you could have the question. Another way that you could have a question on average would be like this. So I'm going to twist this question around a little bit. So let's say question 1, and let's call this 2. Okay. Let's assume that the average of 3 numbers the average of three numbers is 8 if two of the numbers are 5 and 9. What is the third number? Okay, what's the third number? Okay. So for a problem like this, we have to think of what the average means, all right? So we said that the average is adding all the numbers and dividing by the number of numbers being added. Okay. Now, I don't know the third number in this question. So I'm going to say that the third number will be X. I'm going to use a variable to represent the third number. So I'll say let X represent the third number. Okay, X the third number. So if X is the third number, how can I find the average? So the average that I have to find would be X plus 5 plus 9, adding all the three numbers. And if I divide this by 3, where there are three of the numbers, I should get an average of 8. Okay, this is the algebra approach. So how do we solve this? So I have to add the like terms, 5 and 9. So if I add, I get 14, right? Over 3 is equal to 8. What do I do next? I have to get rid of the denominator, which is 3. How can I do that? I can multiply both sides by the reciprocal of the denominator, which is 3 over 1, right? Or it's simple, just say you can cross multiply what we have here, all right? So got this like over 1. So you can do cross product since it looks like a proportion. Okay. So that's one approach. Or, as I said, we can just multiply both sides by 3. So you multiply the left side by 3. Whatever I do the left side, do the same to the right side. Okay. So this is like 3 over 1. In other words, this 3 will cross out. So we end up with x plus, excuse me, we end up with x plus 14 is equal to 24. And then you subtract 14 from both sides. You see, we perform the opposite action, the additive inverse, which is subtraction. If it's adding, you subtract. So I want to get rid of plus 14. So subtract 14 from the left side, subtract 14 from the right side. All right. So anytime you move a number across the equal sign, this 14 went across the equal sign, so it becomes minus. So I have x equal to 10. And this is the number that you're looking for, the third number. Okay, so you can always check your answer by adding them and dividing by 3 and see if you get the average of 8. Okay. Now, another way you can do this if you are not too sure of yourself on an exam, because the answers are already given, right? We can do back solving. So back solving, it's a very good approach to answer questions. So in that case, you take the number, the answer that's given, add them to the other two numbers and divide by 3 to see if you can get the average that is given. So you can work backwards, right? But you need a concept of average to do that, right? So I hope this helps out a little bit. Okay, great. The next topic that I want to look at is a little bit of overview of exponents, exponential functions. And then we want to look at the properties of exponents. So let's begin by defining what an exponent is. So an exponent or power tells you how many times to multiply a base by itself. Tells you how many times you have to multiply a base by itself. Okay, that's an exponent. Okay. So if you have something like x raised to the power b, all right? Now the base is this number here, that is the base. And then the superscript over here is the exponent or the power. Okay, all right. So for example, if I have 5 raised to the power 3, right? So the 5 is the base, and then the 3 is the exponent. So what does this mean? This means that 5 raised to the power 3 means that the base, take the base, which is a 5, and multiply itself 3 times, because the exponent is 3. The exponent tells you how many times you multiply the base. So I multiply 5 by itself 3 times. Okay, so it's 25 times 5, and then that gives us 125. Okay, all right. So don't ever multiply the base by the exponent, and then say that this is 15. No. Never ever do that. Don't do and say this is 5 times 3, 15. No, it's never done. Never ever do that. Okay? Because the exponent the power tells you how many times you have to multiply the base by itself. Okay. Now let's look at another example. If I have x to the power 5, what does that mean? This is not 5x, right? It means that the base, which is x, multiplied by itself 5 times. Okay, that's what that means. Okay, so I hope you get this. Okay. So let's look at some of the properties of exponents. The first property that I want to talk about is known as the power rule. The power rule of exponents. So what does the power rule say? The power rule says that if you have x raised to the power 2, and this is again raised to another number, let's say 3. The power rule says that you multiply out the exponents. So this is equal to x to the power 2 times 3. So it becomes 6, right? You multiply out to the exponent. In other words, let's put that in variable form. You have x raised to the power m, all this raised to the power n. You have x to the power m times n. That is the power rule. Then you have the quotient rule. Quotient rule. So in the variable form, this is the quotient rule. So the quotient rule says that x to the power m divided by x to the power n. Now this is equal to write down the base, same base. So write down the base, and then the exponent will be m minus n. You subtract the lower exponent in the denominator from the exponent in the numerator. So the top exponent minus the lower exponent, right? So that is the quotient rule. For example, if I have x to the power 3 divided by x squared, this is equal to x, that's the base, raised to the power 3 minus the lower exponent 2. So it's just x to the power 1, which is x. Okay. So what does this mean? This means that, let's explain this, break it down a little bit. It means that I have x times x times x. So that's x cubed, right? Over x squared. It's x times x. So what's happening here? This x here can get rid of this x, close to this x out. This crosses this out. So I left just one x. Yeah, this is just x. So that is what this is about. Okay. Now, somebody will ask me the question, what if the exponent in the numerator is bigger than is smaller than the denominator? We do the same thing. So let's look at this. Let's call this example 2. So let's assume I have x to the power 3 and I have x to the power 7 here. We'll do the same thing. So the quotient rule says that write down the base, then the top exponent is 3 minus the lower exponent. So we end up with x to the power -4. So this is negative exponent, right? Now I'm going to show you the negative exponent rule very soon. When you have a negative exponent rule, it says that take the reciprocal of the exponent of the base, okay? Reciprocal of the base. So this is like over 1, right? So that a base now goes in denominator. So I have x and then 1. So 1 over x, it is. Once you do that, the exponent now becomes positive. So this is the negative exponent rule that I've applied here. I'll mention that shortly. So what does this mean? Let's break it down and see. X cubed is x times x times x over x times x times x times another x, 7 of them, 1, 2, 3, 4, 5, 6, and then 1 more. So see that this x will cross this out, cross out, cross out, cross out, cross out. So you have 1 left, 1, 1, 1, right? So we end up with 1 over x, 4 of them, 4 of the x here. So that's 4 to the power. So this is 4 of the x here. So that's 4. Okay, so that's what this means. So negative exponents takes care of this here. That is what you have here. Okay. So let's write down the negative exponent rule, which is the third negative exponent rule. Now the negative exponent rule, as I said, it says that if I have x raised to the power negative n, to make the exponent positive, I take reciprocal of the base, which is 1 over x. Then the exponent now becomes positive. Okay. Or let's do the other way around. If I have 1 over x to the power negative n, like this, since the base and denominator, reciprocal of that would be just x over 1, which is x. And then once I do that, the exponent becomes positive. So if it's in denominator, you bring to a numerator, and the exponent becomes positive. If it's a numerator, take it to a denominator, and then the exponent becomes positive. All right. So example, if I have x to the power negative 10, and I don't want a negative exponent, this will be what? 1 over x, and the exponent becomes positive. Okay. Now, example for this, you have 1 over, let's say, x to the power negative 8. Since the negative exponent is in the denominator, I don't want it there. Okay, I want a positive exponent. I take reciprocal of the base. So it's x over 1, which is just x. And the exponent now becomes positive. So you can go back and forth like this. Okay, so that's the negative exponent rule. I think I gave the wrong name for the first one here. I said this is the power rule. Actually, this is I have to change the name. This is not the power rule, is the oh no, sorry, it's correct, the power rule. The power rule, let's keep it, sorry. All right, so let's go to the next one. Let's call it 4. Now this one is going to be the product rule. Product rule. Now the product rule says that if I have similar bases, and this raised to the power, let's say m, and another one raised to the power, let's say n, I'm multiplying 2 or more bases, same basis, raised to different exponents. What you do is that you add up the exponents. So write the base and then m plus n. Say sum of the exponents and keep the base. Okay. For example, let's say I have x squared times x cubed, and let me add one more, maybe times x to the power another like 4. Since the bases are the same, we can keep the common base and then add the exponents. So it's 2 plus 3 plus 4, and that gives us x to the power. This is 5, and that is 9. Okay. This is known as the product rule for exponents. Product rule. Okay. Let's go. Okay. So let's add one more rule here. Like 2 more. I have 2 more rules. The other one is a zero exponent rule. The zero exponent rule says that any number raised to the power 0 is always 1. So if I have 2 raised to the power 0, it's equal to 1. Okay, so this will be examples. If I have 1,000 raised to the power 0, it's always equal to 1. Any number raised to the power 0 is 1. Okay. So what do you think this would be if I have x, y, z, and the whole thing is raised to the power 0? What would that be? All right, if you say 1, that is correct. 1, because the whole thing is raised to the power 0. So the entire thing is 1. Okay. That is the zero exponent rule. And the last one that I want to add here is the power of the products. rule. Right, power the product rule. So let's assume that I have x raised to the power m, and then another base y raised to the power n, and the whole thing is raised to the power, let's say, c. Okay. Now you take each base and then at a time, and then you multiply out the exponents. Okay, so you have x raised to the power, then it will be c times m, so it's m times c or mc. And then the second and the other base, take that and then multiply out the exponents. Okay, that's a power of a product rule, power of a product rule. Okay, for example, let's say I have x to the power 3, y to the power 2, and the whole thing is raised to the power, let's make it, let's say 4. All right, this will be x raised to the power 3 times 4, which would be 12, and then y raised to the power 2 times 4, and that would be 8, and so on. All right, that's the power of a product rule. And you can have the same thing, power of a quotient. It follows the same approach. Okay, power of a quotient. So quotient means you're dividing two or more numbers. Okay. So for this, we can say that x raised to the power m divided by y to the power n. If the whole thing is raised to the power c, that will be, right, the base multiplied with the exponents, m times c, and then yn times c. Okay, for example, s squared over y cubed, the whole thing is raised to the power 3. You multiply the exponents, so have x to the power 6 over y to the power 9. You multiply them out. Okay. Okay, great. Now, let me combine all these rules in one problem, and let's see if we can do that together. So I'll ask a question like this: simplify the expression. And the expression would be x squared y cubed over s to the power 4 y squared. And then let's raise all this to the power 2. Okay, let's make it a little bit complicated like this. And then I'll add here that's simplify the expression. Leave your answer without negative exponents. Okay, like this. Okay. Right, so let's begin. So there are two ways you could do this problem. You can either simplify what you have within the parentheses, or you can apply the power of a quotient rule here, before you proceed. So it doesn't matter, you get the same answer. Okay, but let's apply the power of a product rule here. So it means I'm going to multiply out the exponents, right? Multiply the exponent out. This times that, and then this times this. So I'll have x raised to the power 4, y raised to the power 6. Now this exponent also affects every exponent here. So this also you have to multiply this by that exponent and by this exponent. Okay, it affects all the exponents within the parentheses. Okay, so I'll end up with x to the power 8 here, and then 2 times 2 y to the power 4. Okay, is this the end? No, I can go further. Okay, you have to keep going till you have only one base of each. I'm dividing here. Okay, I have this these are alike, okay, and then these are also same basis. So I can simplify them, okay. So to simplify, I'm dividing. So since I'm dividing this x to the power 4 by x to the power 8, I have to subtract the exponent. So this is the same as writing right on the top base x to the power 4. Okay, we're going to write this down. Minus the lower exponent. So minus the 8. Okay, minus. So since I'm dividing, quotient rule, I'll do the same thing for the y. So I write down y to the power 6 minus the lower exponent, which is 4. So what do I get here? I have x raised to the power -4, y raised to the power 2. Okay. Now, I don't want to leave my answer with any negative exponent. So I'm going to apply the negative exponent rule. So remember, we can look at this as if we have 1 here, like over 1, right? So since the negative exponent here is in the numerator, I have to take reciprocal, so it goes to the denominator. So now I'm going to end up with the x, the base x, going to a denominator, and the exponent now becomes +4. Okay, once you switch the position, numerator to the denominator, or denominator to the numerator, the exponent changes its sign. Okay, now the y to the power 4 stays there. So I have this. Nothing else reduced. So this becomes your final answer. So we use the rules and all the rules in different ways, to get the answer. Okay. Now, what I was talking about is the fact that I could have simplified what I have inside here. I could have simplified that first before applying the power rule. I'll come up with the same answer. Okay. So let me try to do that for you to see. So I'll call it method 2. Let's call it method 2. Okay. So for method 2, I'll go into the parentheses and simplify first. Let's rewrite the question. Okay. So if I go into the parentheses, I'm going to simplify this and simplify that. Okay. So what would that be? I have write the top exponent. I'm going to write this down. X squared minus the lower exponent, which is 4. I'm going to write the numerator y cubed minus, I subtract that, and then all this raised to the power 2. What do I get here? X to the power -2, and this will y to the power 1. All this is squared. Now I can apply the power of a quotient rule. I multiply out the exponents, so I'll have x to the power -4, y to the power 2. Since I don't want the negative exponents here, I have to apply negative exponent rule. So what would that be? I have to take reciprocal of this, but this is like over 1, as I said before. So I have y squared stays there over x to the power 4. Okay, goes to the denominator. Okay. We have the same answers. So just practice with the different rules and then find out which one you find easier to use. Okay. All right, so this should be enough for answering questions on exponents. All right. The other thing you should know is how to find maybe square roots and cube roots. Okay. But those ones you can work backwards from the question. When the question is given to you, you should be able to work backwards, use a back solving approach. For example, so square roots and cube roots. Now, let's say I have square root of 16. Now, square root of 16 is equal to 4, right? Because you have what? 16 is made up of 4 times 4. Okay. 4 times 4 is 16, all right? The square root. Now, cube root is finding cube, right? Cube root looks like this. So if I say cube root of 8, this is 2. Why? Because if I multiply 2 by itself 3 times, I'll get 8, because 2 times 2 times 2 gives me 8, and so on. All right. So just remember these things, you know. And as I said, you can always work backward from the answer that's given to you, you know. Now, this can be combined in different forms in a question. So let's say a question like this. It could be given, let's say, square root of 64 divided by 2, right? So how do you approach this? You first have to find the square root of the number given. So square root of 64, that's 8 times 8 gives me 64. So square root of 64 will be 8. You know, do that first and then divide by 2. So that will give us 4, right? Something like this. Now let me throw in another question here in a fraction form. So let's call it question 1. Question 2. What will be the square root of 9 over, let's say, 9 over 25? Okay. A question like this, you can split this problem up, right? Take the square root of 9 and take the square root of 25. You can always split up like this, separate them like that. Okay, because they're all under the square roots. So you can put each of them under the radical sign. We call this a radical sign. Okay, radical sign. So this will give us square root of 9 and 3 and a square root of 5 or 25, which is 5. Okay, like this. So these are some of the ways you could have the problem. Another way you could have the problem is to simplify a given radical. Okay. So let's call it question 3. Assuming that you have cube root of 16. Cube root of 16. Okay, how will you do this? Okay, think about this in 30 seconds. Now, if I look at this question, I can find a number that must by itself 3 times to give me 16, right? But what I could do is to think about a number or some factors of, I break this 16 down to factors and see if I can get the cube roots of one of the numbers, okay? When I look at this, I know 16 is made up of, I can say 8 times 2, you know, that's 16, right? And I can take cube root of that. I know that 8 has a cube. You know, I can take a cube root of 8. Cube root of 8 is going to be 2. If you split this up, you can split this up just as we did in question 2, right? The division problem. I can say that this is a cube root of 8 times cube root of 2. We can separate them like this and put them on the same radical with the same index. So cube root of 8 is 2, but 2 times 2 times 2. Okay. So this is 2. And then I don't know, I have a cube root of 2, so I just keep it cube root of 2. Okay. So this will be the answer that you're going to select in a question like this. Great. Another way we can have a question, let's call it problem number 4, is to add up different radicals, addition of radicals. So let's say I have 3 roots. I'll say maybe root 2 plus 4 root 2. All right, this time I have a number, it's not an index, but it's a number in front of the radical. So it's a coefficient. We'll add this up. Now, think about this like terms, okay? These are like terms, these are like terms, okay? So just as you're going to do 3x plus 4x, you do the same thing here, okay? You add up the coefficients, so add up the coefficient, which is 3 and 4, so that will be 3 plus 4, which is 7. And then you keep the common radical that they have in the radicand. Okay, so it is 7 root 2. Just as 3x plus 4x will give us 3 plus 4, which is 7, and keep the common variable that they have. Same approach. Okay, good. So let's try one more. Let's have 2 root question 5. Let's make it 5. Simplify 2 root 3 plus 2 root 2 plus 3 root 3 plus 3 root 2. Okay. Now, when we look through this, I can see some like terms. So I see that this here is the same as, similar to this. Okay, they're like terms. So let's combine them together. So I have 2 root 3 plus 3 root 3. And the other like terms that I have here is this and that. Okay, so I can combine them too. So I'll say plus 2 root 2 plus 3 root 2. Now, if we add this together, this is 5 root 3 plus 2 plus 3, that is 5 root 2. Okay, so add the coefficients. These are like, put them together. 3 and 2, that's 5. Get a common radical. 2 plus 3, 5, common radical. Okay, so this will be your answer for a question like this. Great, so I believe you've learned a lot in this lesson. All right, so I'm going to end here, and then I'll come up with another video with some more topics. Stay tuned.